Kia ora, here's question 4C from this year's WC Scholarship Calculus exam. So this is a really old one from a scholarship paper written by Mr. Vaughan and Mr. Clark about 12 years ago. And it's a question where it looks really hard, but we tell you what you have to do if you read through it slowly. So let's have a wee look. We've got a solid and it's created by rotating this curve. So this is just a section of y equals sine of x. And it's being rotated about the x-axis between x equals 0 and x equals pi on 2. So straight away you should think, okay, volumes of solids of revolution, which remember used to be in the curriculum, but it was taken out, I think, in about 2013. But we've done them heaps in class on purpose because they are super cool and they're a really nice application of integration that we can do at level 3. So they tell us that the centre of mass of a solid is effectively the point through which the entire mass of the body can be considered to be acting, right? Blah, blah, physics. In this case, due to the symmetry of the shape, it has to be at some point x bar somewhere along the x-axis. And we can find it using this expression. So the centre of mass is m divided by v. So v is the volume of the solid, and m is this integral here that we have to figure out. Now, one thing that a number of you kind of missed in this question is that when we're looking at m, and it's this integral, so between pi on 2 and 0 of pi x y squared dx, I think about 5 of you did some really weird things where you thought we had to integrate with respect to y, and we don't. We know that y is equal to sine of x. So what we have to do is to replace y with sine of x. So that's going to give me sine squared of x. And v is the volume of the solid. So I put this note in for us this year, just to remind you how we find the volume of a solid. I'm going to go over that again now. Suppose that these are my axes, and this is my f of x curve. Well, the volume of the solid is going to look something like this. Oh, I can't draw upside down, but you get the idea, right? So remember that what we're doing when we find the volume of that is we're adding up a set of discs. So if you can imagine taking your knife and chopping through, let's see if this laser thing works. Yeah, so it kind of works. Look, if we chop through everywhere, we build up a series of circles, and the area of a circle is pi r squared, and that's where this formula comes from. Okay, so again, if you're watching this and you're panicking before the exam, or you're watching quite early in 2026 and you don't know how to do volumes of solid, go and find my AS revision videos, or just email me and I'll tell you where you can find them. So what we've got to do here is we've got to figure out V, we've got to figure out M, and then we go M divided by V. So let's start with V, which is the volume of the solid. So V is going to be the integral from pi on 2 to 0 of pi, and then sine squared of x dx. Now, we should look at sine squared of x and know from achieved level 3 calculus stuff that we can't easily integrate that by doing backwards polynomials, because we're going to have a backwards chain rule problem. So what we need to do is to replace this with one of our trig identities, and the most useful one that we've seen all year is cos of 2x. So if we take cos of 2x is equal to 1 minus 2 sine squared of x, we can rearrange that and we get sine squared of x. So first of all, 2 sine squared of x is equal to 1 minus cos of 2x, and that gives me sine squared of x is equal to a half minus a half cos of 2x. Now this was actually pretty well done. I was really pleased with how you guys went with this in the exam. I feel like I've hammered in the double angle cosine lots and lots this year. So now we're going to rewrite V, and it's going to be this integral. It'll be pi on 2 into 1 minus cos of 2x dx. I'm going to pull that pi on 2 outside and get on with doing my integration. So I get x minus, now leave a gap, it'll be sine 2x. Sine differentiates to give me cosine, and I need to divide it by 2. So we want to have minus a half of sine 2x. And then as usual, we're going to check that back before we go any further. So just quickly in your brain, let's differentiate negative a half sine of 2x and check that we get back to negative cos of 2x. It's very, very easy to make errors with your negative signs and with the coefficients in integration. But that looks good. So off we go and do our substitutions. So it's pi on 2. Substituting in here, we get pi on 2 minus a half sine of pi minus 0 minus 0. Now sine of pi is 0, so this whole thing works out to be pi squared on 4. Next up, we have to integrate m, which is slightly harder. So I think I gave 1 mark for each of v and m, and then 1 for putting it together. But I can't remember, so please don't come at me if I've done something different from that. Right, right. We have to go back to the start, actually, to look at what m is. So m is this integral here, pi on 2 to 0 of pi xy squared. So a little bit trickier. So it's going to be x, and then y is sine of x, so it's sine squared of x dx. We're going to use the same thing as before, the double angle. We've already done that work. So it's pi on 2 to 0, it'll be x times 1 minus cos of 2x dx. Now I want to expand that out. I'm going to get pi x minus x cos of 2x dx. Now looking at this bit here is going to be very easy to integrate. This is going to need integration by parts. So I'm going to get the easy bit done first. So we get equals pi times x squared on 2 from pi on 2 to 0 minus, let's have a look. I feel like I've lost a half in here somewhere, haven't I? Yeah, I've lost a half, guys. Let me just go back. Oh, I love that this video is unlisted, so no one can see and tell me that I've done it wrong. Okay, in here, this is not this, so I need to have this divided by 2. So I'm going to do that out here. Right. And that is going to give me pi on 2 here. And I'm going to have pi on 2 here. Right, I think we've fixed that up now. So it equals pi on 2 times the integral between pi on 2 and 0 of x cos of 2x dx. Now just before you go anywhere, just have a look and notice that we've got to be really careful with the minus here and with the pi on 2. So we're going to be doing quite a bit of checking at the end, or kind of as we go. So in here, we've got pi on 2 times pi squared on 4 divided by 2, so pi squared on 8, minus pi on 2, now big bracket, let's have a look. IBP, we're going to want to leave this one and differentiate this one, and we'll integrate the cos of 2x both times. So we get minus pi on 2 times, right, let's leave the x, integrate cos of 2x, gives me half sine of 2x evaluated at the limits, minus the integral of 1 times a half sine of 2x dx. Right, so quite a few bits to that. Let's go slowly. We've got pi cubed on 16 minus, right here we've got pi on 4 times, the pi on 4 is pulling this constant out to the front, pi on 4 times pi on 2 times sine of pi minus 0. So all of that bit is going to go away. So let's just write on there that that's 0. And now we're going to have plus pi on 2 times this integral. Let's see. Right, cos of 2x, which will differentiate to negative sign. So we need negative, and we need negative 1/2 times 1/2. Again, if you're watching this early in the year, in 2026, because I'm going to post these videos for you guys to see this year's exam, I want you to notice how fluent you have to be with all of your integration. It's not going to work if you haven't done tons and tons of examples that are at merit level. Okay, you're wasting your time. Right, so minus pi on 8 times cos of 2x, so cos of pi, minus cos of 0. That's going to give me pi cubed on 16 minus pi on 8. Oops, don't know what that line was. There we go. So what's cos of pi? Cos of pi is -1 minus 1. So we get pi cubed on 16 plus 2 pi on 8, which is pi on 4. Right, so all of that work, that was quite a bit of work, and that got me m. And my final bit is just to put m and v together. Right, so the centre of mass is equal to m over v, which is pi cubed over 16 plus 4 pi over 16 divided by v, which is pi squared on 4. So working slowly, we get pi times pi squared plus 4 over 16 times 4 over pi squared, which gives me, let's see, that gives me 4, and that pi go. So I get pi squared on 4 pi plus 4 on 4 pi. You would have got 4 marks for getting to here, by the way, but let's just fix it up. So we get pi divided by 4 plus, I've done something wrong. What have I done? Now I have to pause the video while you all watch me try and fix up my mistake. Let's see. Pi cubed plus 4 pi times that. Let's see. Okay, I'm leaving this in because I think this is a good example of what happens when you just go a bit too fast. So let's just get rid of all this. I'm just going to go back to where I know I was right. Okay, one day this will happen to you too when you're making a stupid video, right? Let's see what we've got. So we've got pi cubed plus 4 pi divided by pi times pi. We've got 16 here, and we've got times 4 here. Right, let's put this in brackets. The 4 and the 16 cancel out, and that gives me that. So now I'm down to 4 pi cubed plus 4 pi divided by 4 pi squared. I'm still not getting what I got in my answer, guys. This is really whack. Right, okay. We've got pi divided by 4 plus 1 over pi. I don't think that's what I got for my answer. I'm sure I had an extra 4 in here. Okay. This is just highly, highly annoying. 4 pi on 16 divided by pi squared on 4. Yeah, we've done it wrong for the 3rd time. Okay, I'm sure that by now you've all stopped watching and gone to sleep. But let's fix it again. Right. This gives me pi cubed plus 4 pi divided by pi squared times 4 over 16. That's better. Pi cubed plus 4 pi over 4 pi squared which is giving me pi over 4, and I'm getting 1 over pi, not 4 over pi. All right, something's gone wrong. It's too late to worry about it. Guys, I will have a look at my stupid mistake in the morning and see what I've done. But that's it for now. Thanks for watching. If you got this far, congratulations. You definitely deserve some form of chocolate fish.